All right, y'all, here we go. I am doing this in my car, so while I wait for my kids at piano, hopefully this works out okay. So when we left off, we were looking at putting these into slope-intercept form and figuring out what the y-intercepts would be. So I'm just going to do a quick reminder that when you are putting things into slope-intercept form, you're putting it into y equals, I have it on this, sorry, y equals mx plus b, or in this case, since we're doing inequalities, y is greater than mx plus b, y is less than mx plus b, but you want your x term to be first because that m in front of the x is your slope. So for example, x is 1/2 x plus 3. This is your slope, and this is your y-intercept. So that's part one to that. The other piece is if you are trying to solve for your, let's make this much bigger. If you're trying to solve for your y-intercept and your x-intercept, you're making the other variable 0. All right, so if you make x 0, then that will give you your y-intercept. If you make y 0, then that will give you your x-intercept. And that's where the line is crossing the x-axis and the y-axis. All right, so when in doubt, to find a point, you can substitute 0 for x, or you can substitute 0 for y, and that will help you to graph. All right, so you can either use your slope or you can create 2 points on your graph by looking for your x and y intercepts. Let's take a look at these as examples. So graph the inequalities. So if I'm going to graph these inequalities, I first, of course, need to put this into slope-intercept form. So we have x plus y is less than 10. And so I'm going to subtract x from both sides, and we'll get y is less than negative x plus 10. So then when I graph this, I'm going to start where 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. At 10, because that's my y-intercept, and it's negative, so I'm going down, and it's negative 1 over 1, so down 1 over 1. On your test, if you just plot 1 point on Edulastic, then you should be able to form that line. And this is less than, so it's going to be dotted. And then I'm going to look at what side I need to shade. So I'm going to test a point on either side of the line. So I see that it's less than, so my instinct tells me, let's test a point that is on this side of the line. And so I'm going to go ahead and test 0, 0, because again, that's probably our easiest point to test. We're going to try 0, 0. So if I plug in 0 is less than negative 0 plus 10, that's going to be 0 is less than 10, which is true. So this point works, which means that this side of the line works, and so I'm going to shade this side. If it didn't work, that would mean I should test a point on the other side and shade the other side. All right, the second inequality I'm looking at, let me go ahead and erase this so I have more space, is looking at an inequality of 3x minus y is greater than or equal to 5. Here again, I want to get y by itself, so I'm going to subtract 3x from both sides, and I'll get negative y is greater than or equal to negative 3x plus 5. Again, I'm writing this term first because I want it to be in y equals mx plus b format. Then I'm going to multiply the whole thing by a negative because I want to neutralize the negative in front of the y. When I do that, because I'm multiplying or dividing by a negative, I need to flip my sign. So this will be y is less than or equal to, a negative times negative 3x becomes positive 3x, negative 1 times 5 becomes negative 5. So now I have 1, 2, 3, 4, 5 as my y-intercept, and I'm going up 3 over 1. It's going this direction because it's positive, so 1, 2, 3 over 1, 2, 3, sorry, up 3 over 1, 1, 2, 3 over 1, 1, 2, 3 over 1, 1, 2, 3 over 1, 2, 3 over 1. Okay, and this is a solid line, so I'm drawing a solid line. And then I need to shade in, so I'm going to go ahead and shade on the other side, or determine which side rather. So let's see, I'm looking now at this line, and so I'm going to test the point 0, 0 here. Well, if I plug in 3 times 0 is 0, minus 0 for y is greater than or equal to 5. That is not true. So in this case, I am going to go ahead and shade the other, oops, that's not the highlighter, sorry, shade the other side of the line. And so now we have places where the line is covered by both, excuse me, okay, in here. And so this would be where our solutions are. Now, note that there is an intersection, but this intersection is not a solution because one of the lines is dotted and one of the lines is solid. So just keep that in mind as you're practicing this. Let's take a look at the other one. If we look at this equation right here, then we have x minus y is less than or equal to 5. Now, I can go ahead and subtract x from both sides, and I'll get negative y is less than or equal to negative x plus 5. And then I can divide or multiply by negative 1 and get y is greater than or equal to x minus 5. Okay, that's one way to do it. I'm going to show you another way just for those of you whose brains maybe work a little differently, is that I can also add y to both sides. And then this will be x is less than or equal to 5 plus y. Then I'll subtract 5 from both sides, and we'll get y is greater than or equal to x minus 5. Notice that these two equations are the same, or inequalities are the same, because I would flip this to write it as y is greater than or equal to x minus 5. That is, in fact, the same inequality as what we got over here. So both ways are fine to solve it as long as you get that y on one side of the inequality by itself. All right, so that's one of the inequalities. I'm going to erase this side just so that I have more space over here. And so now I'm looking at 4x plus 3y is greater than 9. I'm going to go ahead and subtract 4x from both sides. We get 3y is greater than negative 4x plus 9, and divide both sides by 3. Get y is greater than, I'm leaving this as a fraction, negative 4 over 3x, because that tells me how far up and over I'm going, plus 3. Now it's time to graph, so let's go ahead and do that the best that we can. I have the little dots to kind of help me over here. All right, so negative 5, 2, 3, 4, 5 is my first y-intercept, and I'm going up 1 over 1, because it's a positive slope of 1 over 1, and it is a solid line because it is greater than or equal to. It's greater than and equal to, I'm going to test 0, 0 here. 0 is greater than or equal to 0 minus 5, which is 0 is greater than or equal to negative 5, which is true. So that means this side of the line is going to be shaded. If I graph the next one then, it's going to be positive 3, 1, 2, 3. And it is a negative slope, negative 4 over 3. Okay, so 1, 2, 3, 4 over 1, 2, 3. 1, 2, 3, 4 over 1, 2, 3. All right, I can connect those dots, and it is greater than, so it is a dotted line. And then in terms of shading, let's figure out what I'm going to shade. I'm going to go ahead and shade. If I test 0, 0 for this particular line, if I plug that in, I would have 4 times 0 is 0, plus 3 times 0 is greater than 9. That is not true. So this point does not work, which means that I need to highlight the other side of the line over here. And so now we can see that this area right here is where we have double shading. That's where our solutions are. Again, we have one line that is solid and one line that is dotted. So this right here is not a solution to both inequalities. It's only a solution to one, and therefore is not a solution to the system of inequalities. Okay? Let's look at this one. This one's actually done for you. I showed you that in a system of equalities, or system of equations system, that these right here are where our solutions are, where the intersection is. And that's when we have an equal sign between the values, okay, the terms. So in these examples, you have, notice, an equal sign there, all right, not an inequality. Here then, even though you don't know what this weird curvy line is, it's called a parabola. We'll learn about it, I promise. You're looking again wherever the intersect. So here we see an intersection, and here we see an intersection. And so those will be your solutions. So you're going to fill in 2 points where they intersect, and that is your solution. Let's take a look at this one. It says, what would the inequalities above be in slope-intercept form? Let's see if my computer is like cooperating now. Let's try. And so if we're doing this, we're going to solve for y. Sorry about the dog in the background. My goodness. Okay, it's very loud. So subtracting 3x on both sides, we'll get 2y is greater than negative 3x plus 8. Divide both sides by 2. Remember, every term needs to be divided by 2. We get y is greater than or equal to, or sorry, not greater than, just greater than negative 3 over 2x. That's a 3 over 2x plus 4. All right, so now we have a y-intercept of 4. So 0, 4 is our y-intercept. Our x-intercept would be if I plug in 0 for y, what does x equal? So that would be 3x plus 0 is greater than 8. So x would be 8/3. So this would be 8/3, 0 for the x-intercept. Okay, let's look at the other one over here on this side. If we have 2x minus 3y is less than 9, okay, if I want to solve for slope-intercept form, I'm going to go ahead and subtract 2x from both sides. So that'll give me negative 3y is less than negative 2x plus 9. Divide both sides by negative 3. Now again, I'm dividing by a negative, so we're going to convert this to y is greater than. A negative divided by a negative is a positive, so 2/3 x. And then a positive divided by a negative is a negative minus 3. So here my y-intercept I know is 0, negative 3. My x-intercept, again, I can figure out by plugging in 0 for y. So if I plug in 2x minus 3y minus 0 is less than 9, then I divide both sides by 2, we'll get x is 9 over 2. And so this then would be 9 over 2, 0. All right. I'm glad this is working out fine. Okay. Graph the inequalities. I'm going to watch the video, for example, I'm going to show you now. So this is similar to what you just did above. You're going to solve for your... Oh, I did this twice? Hold on a second. I did this twice. Sorry. Just ignore this. It's on here twice. Sorry, y'all. I didn't even catch that. Okay, so this is the same as these here, which we already did a moment ago, all right? So you can just cross those out because you realize that Ms. Lee accidentally put something twice. Oop, that's the wrong thing I wanted to show you. Here we go, split view. 3, 4, that's what I want to show you. All right, so those graphs that we did earlier, those are the inequality graphs for that one that I actually put on here twice. Sorry about that. All right, this last one says, look for whether the line is dotted or solid, right? It's giving you some solutions and some ways to analyze which equation matches this graph. So let's look at this carefully. We have a dotted line for one with a negative slope, and then we have a solid line for the other with a positive slope. So that means that whatever we choose should have both a less than or equal to and a less than or a greater than. All right, which it looks like all of these do. So any of them could be options. Now I've already done this one for you and have this highlighted here, but let's take a look at y. So not at y the letter, but at W-H-Y, y. Okay, so this one here says that our y-intercept is 2, and this is the one that should have a solid line. So here, let me see if we can zoom in a little bit. It's actually really hard to zoom in on this. Oh, actually, that might not be the answer. I don't know why I bolded it then. But let's take a look at this. So here, for the less than or equal to or greater than or equal to 1, you have a y-intercept of 5. So we're looking for one that would have a y-intercept of 5.